Continuing on with Unit 1, we're now going to take a look at even and odd functions. To get started, we first want to appreciate the symmetry of the situation, because that's one of the advantages of even and odd, is understanding the symmetric properties. So I have a case for each up here, and let's take a look at the first one. Now, if we were to have an even, it would have to be symmetrical with the y-axis. So if I had something over here, it would be symmetrical over here. We just reflect it across, so every single point would be reflected. One of the most classic cases, of course, is our y is equal to x squared, where I have x is equal to 2 be 4, and x is equal to negative 2, and that'd be negative 4. So we know we don't have an even right here just by glancing at it. But let's see if we have an odd. An odd is also symmetrical, but what we do is we have, in essence, a double translation. A little bit more complicated than that, but we're going to start off with that idea first. So I reflect this across the y-axis, and I'm just estimating the point, and I reflect again across the x. So I can do that for every single point. I would reflect. I could also go backwards in a way, reflect and then reflect that way. And also another indicator is that it passes through the origin. So we have ourselves an odd. Even, as I mentioned before, when I reflect across, this is exactly symmetrical across the y-axis. So this is an even. And of course, this is going to be a neither, because if I were to try to reflect this, there's nothing that exists over here. And if I'm trying to reflect across the y, it's just absolutely missing. So this is a neither. But one of our challenges is going to be looking at these things algebraically. So when we look at it algebraically, we have to remember a couple of our rules, almost like test rules. We're going to have an even if we just do f of x and we substitute in the opposite of x, f of negative x. If these two are equal, we have an even. If we have f of x is equal to negative 1, or the opposite of this, we have ourselves an odd. And of course, if we don't have any of this, it's not going to work out, and it'll be a neither. So let's go ahead and test this out. Now, looking at this, I am predicting an odd. For one thing, if I were to substitute zeros in here, I would get y is equal to 0, and it passes through the origin. But I'm not for sure yet. Let's see what happens. So I'm going to do f of negative x is equal to negative x to the third minus negative x. I need to simplify that. Well, that's still going to be negative x to the third. Okay, and that is going to be plus x. Now what I can do is I can factor out a negative 1. Let's go ahead and do that. X to the third minus x. Well, this right here is my f of x. This is my f of x right here. So what I have is negative 1 times f of x. All right. So we have our rule, f of x, is not equal to f of negative x, so we know it's not even, but it is equal to the opposite of negative of f of x. So we have an odd. And I'm going to show you real quick on the calculator. So what we have here is we have this function right here, and when I graph it, it's symmetrical. I have that point reflected and down. Okay. I can reflect and down, reflect, and of course it's across the y-axis, so that point will be up there, and 0, 0, so on. So I have very much an odd looking, well, pun, equation. All right, so let's take a look at the next one. I have, well, you're going to be famous on YouTube. Now, so what I have here is I have 3x squared minus 5. I'm going to do my f of negative x is equal to 3 times negative x squared minus 5. Well, that's just going to be equal to 3x squared minus 5. So guess what? My f of x is equal to, because this is my f of x, f of negative x. All right, so I have an even. You probably can guess what's going to happen here. So I'm going to have, I'll do this in green, I'm going to have f of negative x is equal to 2 to the negative x squared plus 7 to the negative x. I didn't mean to put that in parentheses, minus 9. So I'm going to have negative 2x, positive 2x squared, minus 7x, minus 9. I can't factor out a negative 1 and end up with this right here. So this will be a neither. Alrighty. So that is it. I'm going to go ahead and get these loaded up and get back with you on the next one.